Finding derivatives, page 37 in your notes. Please copy down the following notes and pause the video in order for you to get the information written down. So the definition of a derivative. We've talked a little bit in limits, and now we're going to learn more about taking derivatives. The derivative is the slope of the tangent line to the graph at a specific point. So the reason why we do take the derivative is because it makes it easier and you are finding the slope of the tangent line. That's what a derivative is. If the graph has a sharp cusp or corner, then it has no derivative at this point. So there's two key sentences that are important for this unit. In this example, there is no derivative at x equals 5, and we state that f of x is not differentiable at x equals 5. And the reason is because that sharp point at x equals 5. The derivative, you're going to identify the slopes of the derivative, and you're going to estimate the slopes, whether it's positive or negative. The graph of f of x is shown below. It says sketch the graph of its derivative. So if you take a look at the parabola on the left, the parabola is upside down, which means that it's negative. Okay. At x equals -2, it would have 0 slope. And a parabola, any general parabola, is y equals x squared. So if I was to take the derivative of x squared, it becomes a line. And the 0 remains where that cusp was at x equals -2. And that's why when I draw the line on the right, the 0 goes through x equaling -2. Sketch the graph of the derivative if the graph of f of x is shown below. So f prime up there with the little marking, that means for you to take the derivative. And notice the cusp at the bottom of the parabola occurs at x equals 3. So at x equals 3, that's going to be a 0 on the derivative. So when I draw my line, since my parabola is positive, my line has to slope to the right, and it has to go through x equals 3, because that's where a cusp occurred. Here I have a line where my slope is m equals 1. The reason why I know it's 1 is because I rise 5, run 5. So my slope of 5/5 equals 1. So if my slope is 1, the derivative of a line is where my slope is 0. So my line becomes y equals 1. The slope moved from 1 to, after I take the derivative, my slope is 0. Here I have a cubic positive graph, and I notice cusps at x equals 0 and at x equals 2. A cubic graph becomes a parabola, and I need to have the same zeros at x equals 0 and x equals 2. So my parabola, since it was cubic positive, my parabola becomes x squared positive. It says sketch the graph of f of x if the graph of the derivative is shown below. So here we have a line. This is the derivative. Now I want to know, well, what's the original? If I have a diagonal line, that means that the original graph had to have been a parabola. And notice that I have a 0 at -2. So since I had a cusp at x equals -2, and it was a positive line, diagonal line slanted to the right, I have a parabola, positive parabola opening up at x equals -2. I don't have to know exactly where that parabola is. I just need to know that it's a positive parabola. Here's the derivative. It's parabola and it's x squared. And notice my zeros are at -2 and 3. So since it was a parabola as the derivative, the original graph has to be a cubic graph. A cubic graph that has the cubic graph going through -2 and 3. And you can see that at -2 and 3 are where my cusps are, my humps and my valleys of my cubic graph. And those points aren't exact, so I just have to make sure that they're at -2 and at 3, and it's positive cubic. Because I had a parabola that was positive, it opened up. So to find the derivative, there are different ways of writing the derivative. So you could write, if the original graph was f of x graph, you could write f prime of x or y prime. And sometimes we use dy over dx. So you'll see that a lot written, say, in textbooks. They'll use dy over dx, or they'll use df of x over dx. But for most of our equations, we're just going to use the prime symbol. But any one of these could be used, and so I just want you to be aware of them. If f of x is 2x squared minus 5, find the derivative. So dy over dx means find the derivative. So what I have to do here is I'm using formula 2, and inside where it was x, I'm going to place x plus h. So I'm doing the difference here, where the limit of h approaches 0. And you can see I have 2 times x plus h squared minus 5 minus 2x squared minus 5 all over h. And then the rest is basic algebra. You have to remember to FOIL. You have to remember to rainbow. You're going to cancel. And at the very end, h will approach 0. So as h approaches 0, the derivative of 2x squared minus 5 equals 4x. If f of x equals x squared minus 2x, we're going to find the f prime of 5. So first we're going to do the derivative, and then we'll sub in 5 in the end. So in the x, you're going to plug in x plus h squared minus 2 times x plus h minus the original equation of f of x all over h. Again, your algebra skills need to come into play where you're foiling the first bracket, rainbowing in the -2, and rainbowing in the minus sign. Combine like terms. Cancel your h's, and an h has to be common to all of them. And in the end, the limit is where h approaches 0. So my derivative of x squared minus 2x equals 2x minus 2. Now I need to substitute 5 into this expression because this is the slope. Remember, the derivative is the slope of the tangent line. So I plug in 5. 2 times 5 minus 2, your answer is 8.